So let's look at nomenclature here of aromatic compounds. So we talked about how to name monosubstituted benzenes in first semester, but with just a substituent, we would call this bromobenzene. That's an ethyl, so here we have ethylbenzene. Now there are some common names that we do need to commit to memory of these monosubstituted benzenes. So we've got toluene, phenol, aniline, benzoic acid, benzene sulfonic acid, anisole, and styrene. So you may have heard styrene before in the word polystyrene. So those we need to commit to memory because sometimes that will be the parent of our compound. Now the numbering, just as a little review, ortho is 1, 2, meta is a 1, 3, parent is a 1, 4. And so here we have a 1, 2, that's ortho. We could call it 1, 2 dichloro. Right here we have meta-nitrotoluene, so that's 1, 2, 3. It's a 1, 3 orientation. And here we have para, that's a 1, 4 orientation of those two substituents. So as far as naming these larger things, we want to use the lowest possible numbers to indicate the position of the substituents. Right, so there are some special groups that we see from up above that we put at position number 1. So let's look down below here at these examples. So here we have toluene, so that's your parent here. So toluene. And then we have substituents at 2, 3, 4, 5, 6. So 2, 4, 6 trinitrotoluene, otherwise known as TNT. So here our parent is phenol, and we have substituents at 1, 2, 3, 4, 5, so 3,5-dibromophenol. And then down here below we have basically this molecule being named as just benzene. Now, how does the numbering work with this? Well, you have chloro, bromo, and ethyl. We want the lowest possible numbers. So a number 1, a number 2, 3, and 4 works well here. If we number it the other direction, that would be 1, 2, 3, 4, 5, or 1, 2, 3, 4. So that numbering gives us the lowest possible numbers. So 1 chloro, right? Bromo comes first, and then ethyl comes last. So 2 bromo, 1 chloro, 4 ethyl benzene. Now, occasionally the benzene ring itself can be named as a phenyl group. So in this example, we have ethanol here. And sticking off of that carbon, we have a phenyl group, so 1 phenyl ethanol. And then kind of wrapping this up, you can see this nomenclature is fairly straightforward. There's a couple polycyclic aromatics that you need to know also. So naphthalene, this is an aromatic compound that's often used in place of benzene these days in some labs, and anthracene. Now, other thing to point out to you here too, and I just want to make a little point of this, when that benzene group is simply a substituent, remember it's called a phenyl group. So it's a phenyl group. It's abbreviated a PH, or this little 0 with like a line down it. So a phenyl group is different than a benzyl group. So a benzyl group has this additional, at this position here, this additional CH2 group. So it's a CH2 ring. That's what a benzyl group is. And a phenyl group is just the benzene ring by itself. So the nomenclature there is to just kind of watch out for that situation because it does arise sometimes.